Find the measure of the angle ACB for A, B, and C with the coordinates given there. So we have to find the angle in C. So if we have C here, and A for example here, we can draw CA. So let's say this is C, and here you have A, and this will be the vector CA. And let's say that B is here, so this will be the vector CB. We have to find the angle in C, so we have to find this angle. Let's call this angle theta, for example. First of all, we have to find the vector CA and CB. To find the vector CA, we know the coordinates of the point C and the point A. So the vector CA the x component of the vector should be equal to the x coordinate of A minus the x coordinate of C, so minus 1. And for the y component, it's going to be the y coordinate of the point A, so minus 1, minus the y component of the y coordinate of the point C, so 4 minus 4. That is going to be equal to 3 plus 1. And here minus 1 minus 4 is minus 5. So the vector CA has components 4 minus 5. Okay, that is for the vector CA. And for the vector CB, it's similar. So we have to, for the x component of the vector, we do the x coordinate of the point B, so 2, minus the x coordinate of the point C, which is minus 1. And for the y component of the vector, we do the y coordinate of the point B, so the 0, minus the y coordinate of the point C, which is 4. So that's going to be equal to 2 plus 1 minus 4, so 3 minus 4. Those are the components of the vectors CA and CB. If we use the first method, so the first method to find the scalar product of the vector CA and CB, so the scalar product of those two vectors. If we use the first method, then we do the magnitude of the vector CA, so the magnitude of the vector CA times the magnitude of the vector CB, the magnitude of the vector CB times the cosine of the angle between those two vectors. So that's actually the cosine of theta, and we have to find this angle theta. So we can move the magnitudes, those two, to the left hand side, so we can have an expression for the cosine of theta. The cosine of theta will be equal to the scalar product of the vector CA and the vector CB over the magnitude of the vector CA times the magnitude of the vector CB. Or the cosine of theta will be equal to the scalar product of the vector CA and CB will be equal to the x component of the vector CA times the x component of the vector CB plus the y component of the vector CA, which is minus 5, times the y component of the vector CB, which is minus 4. And the magnitude of the vector CA is equal to 4 squared plus minus 5 squared, and the square root of this, times the magnitude of the vector CB is equal to 3 squared plus minus 4 squared, and the square root of this. So the numerator will become 12 plus 20, and the denominator 4 squared is 16 plus minus 5 squared is 25, so that is going to be equal to 41. So we have the square root of 41. Here 3 squared is 9 plus 16 squared is 6 plus 4 minus 4 squared is 16. So 9 plus 16 is 25. So we have the square root of 25 here. So in the numerator we have 32, and in the denominator we have 5 times the square root of 41. To find the angle theta, we do the inverse cosine of the expression that we found for cosine of theta, so the inverse cosine of 32 over 5 times the square root of 41. And if we do that, we will find out that it's equal to 1.79 degrees.